Alright, this video is to help understand the concept of finding the distance between 2 points. So we're going to give a few examples here and show you 2 different ways how to do this. And then we have a worksheet on the website which will allow you to do some extra practice and have the answers on there for you. So here's the first point we're going to start with, or the first 2 points. -6, 4, and 5, -9. We want to find the distance between those 2 points. So there's 2 ways to kind of do this problem. One is if you just memorize the formula, the distance formula, and then also is more of a, if you don't know what to do, just draw a graph and you can use the Pythagorean theorem. So I'm going to show you both ways. First I will be just using the distance formula, which is something you might want to memorize if you struggled with this concept before. So the distance formula is the square root of, I'm going to take my x's minus each other. You can really write an x1 and minus an x2 if you'd like, but as long as you keep the order the same when you do your y's later, and it doesn't really matter which one goes first, but I'll write x1 minus x2, then that quantity squared, plus our y's subtracted from each other. We have to go in the same order that we subtracted the x coordinates from each other, and those are also squared, that quantity squared. So that's the distance formula, and I'll show you how to get that in the second version of how to do this problem, or how to do a different problem if you don't remember the distance formula. But you can just memorize that if you'd like. So now I'm just going to plug in my points. So the distance is the square root of my x coordinates minus each other. I'm going to call this one x1 and this one x2. Okay, so I'm going to take -6 minus 5, and that quantity squared. Then I'm going to add my y's, and I'm going to say this is y1 because it had to go with the x1 point. So y1 is going to be 4, so 4 minus, make sure you have a minus there, and the y2 is -9. So I really have a minus sign and then -9, and then that's quantity squared. That's why there's 2 kind of negative or subtraction symbols here, because it was just subtraction and this point happened to be a negative number. So now I'm just going to do the things inside the parentheses next. That's my order of operations. So I have a -6 minus 5 will give me a -11, and then that's squared, plus 4 minus -9. The negative and this minus kind of become a plus, so 4 plus 9 will be a 13 squared. All right, so now I just do inside the square root sign. So I have -11 squared. Make sure if you use your calculator, it should be a positive value as your result. So 121 plus 169. All right, that's what each of those are squared. Now I'm just going to add those together. Distance equals the square root of those 2 numbers added together will give me 290 underneath there. Okay, so that's my answer as a radical. Another video we're going to have on the website is how to simplify radicals. However, if we find factors of 290, none of them are going to help us reduce this any further. So that's as simplified as we can go. And then from there you just type in your calculator how to write this as a decimal. So I'm just going to take the square root of 290. It gives me 17.029386. I'll just write down a few of those there. Speed that up. Okay, and we want it to be rounded to the nearest thousandth, which is the 3rd decimal place over. So those 3 are what I'm going to want to have in my answer. But to round, I need to look at this 4th spot right here and decide, okay, if it's over 5 or above, we're going to go up. So this is less than that, so we're going to keep this as a 9 right here. So 17.029 is our approximate distance. And we could say units here, that would be more technical. So those are the 2 values. This is our radical version and this is our approximate decimal version. So that's if you just memorize the distance formula, which was right up here again. And I'm going to show you how we get that using the Pythagorean theorem in a minute. Okay, so I'm going to have to wipe this out here on our board. I guess I'll just use my hand. That will work. Low budget here. Alright, so now we're going to do a different problem, just again more practice, but I'm going to show you with a different approach here. So here's our new points. So if you're working on this question, say it's on a homework problem or on a test and you don't remember the distance formula, I have 2 new points. I'm going to show you kind of how you could set this up. So I'm going to draw a little axes here and label it 1, 2, 3, 4, 5. Actually, I could have done that on the other side. Oh well. 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. That'll work. 1, 2, 3, 4, 5, 6. Okay, just some axes here, and I'm just going to show you, we're going to plot these points approximately. Now, if you're doing this on a test or something, maybe you just want to sketch the graph. I'm going to try to make it a little more accurate so you can see the points better. So -2, +7 is, I believe, right here. And then 8, -5. I think I made this 8 long, and 6 down, so we're just going to go 1 less than that. Okay, so those are our points there. So what we're going to do with these points is make a right triangle. It doesn't matter if you go down here and then over, or up and then down. So I'm going to go that way, sideways and then down. Doesn't matter, because what we really are looking for is this diagonal line, the length of the diagonal line. Now we're not finding the slope of the line, we're finding how long is that. If you were to take a ruler and measure how long this is, that's what we're trying to find out right now. So let's calculate how long this side is. So this was a 2 over here, this was -2. So to get back to the y-axis point, that would be positive, a distance of 2. To get from my y-axis over to this side is a distance of 8, because this point is at 8, -5. So together, the length of that whole side is worth 10. Okay, so I combine those together. I didn't get a 6, all right, because I have 2 on this side, and I also have 8 on this side of the y-axis, so I have to count them together, even though this was to the left. So same thing over here. Above, this point up here was at a +7 was the y coordinate, so this distance from 0 up is 7. From 0 down is worth 5, so together they make 12. That whole side of the triangle is worth 12 altogether. And I'm going to call this side C, because that's how you usually call this, the hypotenuse in geometry was side C. And I'm going to use the Pythagorean theorem here. So I have 10 squared, my one side squared plus the other side squared equals the hypotenuse squared. All right, so I'm going to just square these here. 10 squared is 100, 12 squared is 144. Equals c squared. All right, and then I'm going to square root both sides. Or I can combine these together first. So 244 equals c squared, and then I'll square root each side. Okay. Now normally when you take the square root, you get a positive and negative number. We're talking about distance, so we're just going to always assume that it's the positive version. Okay, and notice we're doing the same thing as if you were to use the formula here. You combined the x's together, sort of. You didn't add them together, but you combined them to make the distance here, which was the x minus x part from the formula. And here is the y minus y's and part of the formula to get this distance. And then you took the square root of it. So you're really doing the same thing as the formula. You're just maybe not thinking about it as a formula, because maybe this one's more familiar to you, the Pythagorean theorem. So from here, this is okay if you're not comfortable simplifying radicals yet. This is technically our answer. However, we want to simplify it some more. So if you haven't watched that video yet, or if you're not comfortable with it, this is okay for right now. But we really want to get our answers simplified. So if we want to think of things that are divisible by 244 or that can multiply up to 244, some of our options are 1 and 244. That one's kind of obvious. 2 times 122 would give me 244, and 4 times 61 is also going to get me back to this 244 number. So I want to find numbers here that they all multiply back to 244, that's why we listed them, but that one of these is a perfect square, because that'll help me reduce this. So underneath the square root sign, I can say instead of 244, it's the same as 4 times 61, because that still gets you 244. All right. Now what we're allowed to do is we're allowed to split up each of these square root signs. So it's really the square root of 4 and the square root of 61. That's how radical signs work. Okay. Now we picked the 4 versus instead of the 1 or the 2 to use because this is a perfect square. That means I can split it equally into 2 pieces and multiply back to 4. So each of those 2 pieces gets me a 2. So the square root of 4 is a 2. Square root of 61, I don't know that. And there's nothing else that I can reduce that with. So this is also our, well, I was calling it C here, but it's really the distance. So maybe you want to write distance or C. Okay. So here's our distance. This is the most simplified version. This part right here was also the answer. Again, if you're not comfortable simplifying yet, maybe go watch that video or make sure to ask because this is technically not as simplified as it should be. We're looking for this answer. And the last step is just to, again, put either of those into your calculator. Square root of 244. I get 15.620499. Some stuff. Again, we're rounding to the nearest thousandth, so that's 3 decimal places to the right of the decimal point. And I look to the number after that and say, should I round this 0 up or down? I'm going to keep it as a 0 and not round it up. So my distance is 15.620 units. Okay. So hopefully that video helped. If not, make sure to ask your teacher, go to Math Help 3rd through 7th period, and then try those problems on the website. The answers are also included on there, so check your work as you're going.